I didn't see it. I didn't watch the game.
That's my age.
It's not 19.
Drew
It's
Brees.
at all. It was 19.
Yeah.
But no, I don't know. Not-
Loki did not also. Really?
My team did not make anywhere near anywhere. No, nowhere near that.
Good line center break. Yeah, never was something.
Might work, what? Should work. Yep. This is fine now.
I have a total of 10 examples. They shouldn't take too long. 10 sometimes can mean like 2 class periods. In this case, it ought to be about 10, 15 minutes tops. So let's solve some equations. We're going to learn today how to solve equations that don't really fit into any of the other categories. So to this point, you've learned how to solve by factoring. You've learned how to solve by completing the square. We will eventually revisit. The last thing we'll have to do to check the box is the quadratic formula, but I figured I would cash this one in right now. Since the skill required to do this is what we've been working on, so I thought it fit nicely here. But anyways, this one, arguably, you could turn into a difference of squares, just for the record. You could pull the 4 across and factor it down into x plus 2, x minus 2. But we're not going to go that route today. Even when it's a possibility, I would encourage you to go the other route, which is to make it look like this. So once you get x squared by itself, then you're ready to solve. What are the solutions? I mean, the obvious answer is 2, right? Because 2 squared equals 4. What's the other solution? Right. So the solutions to this are very simply just positive and negative 2, right? And the way we obtained that, I'm guessing you know, is that we took the square root of the left side and we took the square root of the right side. Okay. So what happens if it's something like this? Thank you, Landon. Still the same approach, right? You have x squared by itself, so you're just going to take the square root of both sides, and you're going to say that x equals immediately positive negative. Before you even worry about it, just put the positive negative, right? Same as when we're in the middle of completing the square. When you square root in the middle of an equation, you have to incorporate the positive negative scenarios, okay? What's the square root of 80? Good job. Way to do that in your head, right? So it's the square root of 80, which we have seen this number probably several times by now, which we break into root 16, root 5, which means that the solutions are x equals positive or negative for root 5. The 4 coming, of course, from the square root of 16, right? Okay, I got a couple more of these nice little simple warm-ups. I think they're simple. Okay, we have x squared equals 300. What does x equal? Positive, negative. Good job. 10 root 3. And again, that came from breaking the square root of 300 down into the square root of 100 times the square root of 3. And then the last of our little, I think, easy warm-ups is x squared equals 32. What's x? Positive, negative, 4 root 2. Good. So having that experience with the radicals really pays dividends throughout your math career, being able to break those down. If you still can't do that in your head, then just go make a tree with 32, break it into 16, 2, and you'll see where all that comes from. So that's not worth a day. That would be crazy to spend a day talking about that. What we're going to talk about are these. So I wanted to warm up with that because I thought that is the base idea behind all of this is x equals positive, negative something. And again, this one does not fit a mold. This one, by the way, all quadratic equations can be solved by completing the square or by the quadratic formula. But sometimes there are quicker ways. And the ones that I'm talking about today, specifically, you will not see a single math problem today that has an x. They will have x squareds and then you will jump right to the constant term. So they'll all be missing that middle term. Every single one that we do, every single one in your assignment, they're all going to be like that. Thoughts on this one? Why does this one not look like its four predecessors? What's different? There's a 3. How do you suppose we could solve that problem? Getting rid of it. And how, for years, have we been getting rid of 3s like that? By dividing. Good. So if we divide both sides by 3, I'm going to show my work here. I won't always, but there you go. That means that x squared is equal to 5/3. And now this problem is just like his predecessors in that we have x squared by itself, and we're ready to take the square root of both sides. You'll see pretty quickly now why I had you do what I had you do the last couple days, because now we're going to take the square root of both sides, and we're going to wind up with x equals positive or negative √5 over √3. Okay, when you square root a fraction, you square root the top and you square root the bottom. So we don't have to spend a bunch of time today going over rationalizing the denominator, because that should be something that's already pretty well in your wheelhouse, having practiced it to the extent that we did. This answer is not wrong. It's just unacceptable, right, in its format. What are we going to do to fix it? We're going to multiply the top and the bottom of this both by √3. It is quite literally all we've been doing for the last at least 2 days in this class, is rationalizing denominators. So what does x actually equal? Positive, negative, √15 over 3, done. Okay, and again, that's what's nice is having given up those couple of days is that we don't have to sit here and wonder, how did you do that? Because you've been working. And that's just a rationalized denominator, and the answer is now acceptable. Right? Let's go again. 6x squared equals 50. What do we do first? We divide 6, and we wind up with x squared equals what? Just waiting to see what you say. Good job. I was wondering if you'd go that route. You can reduce prior to rationalizing the denominator, and quite frankly, you should. So instead of writing 50 over 6, we'll divide the top and the bottom quickly, both by 2, giving us a 25 and a 3. All right, there's no sense in using larger numbers when you have the option not to. All right, so now it's time to cash it in and solve the equation. So we're going to say now that x equals positive or negative what? I'll write it down for you if you'd like. It would look like this, right? Square root the top, square root the bottom. I was just kind of pausing there to see if any of you would have said, no, not seeing it. I see something I can do. Right. I see, and I'm always going to look for little things I can do, little opportunities I can seize that will make my life just a little bit easier, right? No sense in making math any harder than it has to be. So rather than rationalizing this denominator yet, why don't we just take a quick moment and rewrite it as positive or negative 5 over √3. Grab every chance you get to just chip away at it early. Save yourself from having to go into the larger numbers. Sometimes maybe the opportunities won't be there, but if they are, take them. And now I'm ready to rationalize the denominator. So I'm going to multiply the top and the bottom both by √3. And what am I going to wind up with as a final answer? Good. So we can make a final statement that x equals either positive or negative 5√3 over 3. And had we not grabbed that √25 early, we would have had to reduce that root of 75 down. No big deal. It's kind of light work, but it's better to get it done early. Good, good. Okay, next one. 40x squared equals 27. Just want to, just for clarity, I don't know if you want to write this part down, but since I am recording this, I just want to be as abundantly clear as I can that the way you're approaching this equation is markedly different than how you would approach this equation. I don't mean to insult your intelligence by asking what's different, but you see it, right? So I would not try the shenanigans that I'm doing right now because, yeah, the one on the right is missing a term, but a problem like this one, I would pull the 27x to the other side like this, set it equal to 0, and then I would pull out the greatest common factor, which in this case is x. So I just want to be clear that, when we take notes, when we prepare notes, sometimes lazily we can make generalizations that aren't accurate. Like we can't just think of today's notes as these are the ones with two terms, right? Just because you have two terms doesn't mean you get attacked the same way every time, right? It's a matter of which of the terms is missing. So like this one over here would have answers of x equals 0 and x equals 27/40. Markedly different than what we're about to do, right? Okay, so back to the actual math problem over here. Let's divide both sides by 40. So we get x squared equals 27/40. There's a name for those numbers in math. They're not prime numbers, but they are what we call relatively prime. Okay, relatively prime numbers aren't necessarily primes. They only have a common factor of 1. So because they're relatively prime, we can't reduce it down. So we just dive right in and take the square root. So what does x equal? Positive or negative what? No need to hustle here. What's it going to be, just for anyone who might be just kind of hanging on? There's always people that learn a little faster and slower. So for someone who's a little bit on the struggle bussy end of things, it would just be root 27 over root 40, right? And again, some of you are more pro than others, and you might have skipped that and maybe jumped ahead. I leave that up to you. How do you want to attack this one? I don't want to multiply the top and the bottom both by root 40. Not yet.
Oh, you could. Can you?
I can think about the top. Let's think about the top. Root 27. This is time that's worth it. How do you break down a root 27? Root 9 and root 3, which means that the top is 3 roots of 3. I believe that that will be worth it in the end, rather than having to multiply 40 by 27. What's the square root of 40 break down into? Yeah, again, square root of 4, square root of 10, which is 2 roots of 10. Again, grabbing those early simplifying opportunities will pay dividends. It'll keep us from needing calculators, because calculators really they don't, they're not good for us. Sometimes you got to use it, but most of the time it takes the thought and understanding out of what we're doing. And we don't need a calculator now for the rest of this problem at all. What are we going to multiply the top and the bottom both by? By root 10. So we're going to multiply by root 10 on top and root 10 on bottom. Okay. Again, no need for a calculator. So we're just going to say equals positive, negative what? What's on top? I love that. 3 root 30. And what's on bottom? 20. Is there anything I could do to go further? Can you simplify the root of 30? 30 has always been, in my mind, the most glaring example of a weird root. It feels like it's not dead. You can't. 30 has an abundance of factors. 2, 15, 3, 10, 5, 6, but none of them are simplifiable. Like none of them do you any good. So this would be the final answer right here, is x equals positive or negative 3 roots of 20, or 3 roots of 30 over 20. The only other option would be if these numbers, the 3 and the 20, were reducible, but they're not. Okay. Next one. 75 x squared equals 32. Step 1. Divide 75 on both sides. So we're going to wind up getting ready with this. X squared equals 32 divided by 75. And in its unacceptable form, we can just say, okay, x equals positive or negative root 32 over root 75. But I should never catch you multiplying the top and the bottom by a root when it's not necessary, especially a case like this. Ain't nobody want to multiply by 32 by 75 and then try to break that down. Because again, I want to avoid the land of calculators. You should too. So what are we going to do to the top? What's root 32? We've seen him. Correct. Remember, he starts as a root of 16 and a root of 2. So the top is now 4 roots of 2. Got to grab that low-hanging fruit while you can, right? And what's the 75 going to break down into? We've seen this one before. What are the numbers that break down 75 cents? Yeah, a root of 25 and a root of 3, which makes the bottom 5 roots of 3. Grabbing that early is huge. Okay. If you don't do that, you're going to be trying to break down the square root of, I don't even know what that is. That's big. All right. What are we going to multiply by now? This is a lot easier than it would have been. Yeah, so we're going to multiply by root 3 on top and root 3 on bottom. And oftentimes you'll find this to be just the conclusion of the problem, right? If you missed a little simplifying along the way, sometimes there'll still be a little bit of meat on the bone. But in this case, I think we're probably going to be done. So it's going to be positive or negative what? 4 root 6 over 15. And again, the only opportunities to reduce would be the 6, which is dead, or the 4/15ths, which are relatively prime. So it's dead also. Okay. 2 more. You getting it? So you see now why you have to know how to rationalize denominators. It is expected, just like one day in 4th or 5th grade, it became expected from that day on that you would reduce fractions, right? That was a thing. You learned it when you were like 11. And from that day forward, the answer to the question, should I reduce my fraction, has always been yes. From this day forward now, you now have a new skill. And the expectation is yes. Always rationalize your denominators. So 8x squared equals 27. Divide by 8, you get x squared equals 27 divided by 8. And it's ready. As soon as it looks like that, it's go time. So if I square root both sides of this equation, I get what I'm looking for. I get x equals the positive or negative of root 27 over root 8. And even with little numbers like this, I think you'd be crazy to multiply the top and the bottom both by root 8. You could. What is that? 160, 56, 216? You could handle that. But again, if we can avoid using our calculators, we should. Calculators just, they don't help us. We think they help us, but they don't help us. They don't help us learn. What's the top going to be? Root 27. What is that? Right. And again, I'm just, as a courtesy to some of us that I know still struggle with roots, I'm just going to keep showing how I'm doing this right. Root 9, root 3. So the top is 3, root 3. The bottom is a root 8. What does that break into? Root of 4 and root of 2, which becomes 2 roots of 2. Again, getting it done early is huge. All right, so we'll multiply the top and the bottom both by what? Root 2. Root 2. Let's see if it's a final answer. Let's see how we did. What's the top going to be? 6. So positive, negative 3 root 6 over 4. Still good? Cooking? Last one. Oh, I'm almost out of. Can I get rid of this? Is anyone still writing that down? Okay. I just need a little bit more real estate. I don't see the sense in starting a new page. So I have 252 x squareds equal to 108. And I'm going to go ahead and just do what I do. The first step, I'm like a robot. I'm just going to divide both sides by 252. So I'm going to say x squared equals 108 over 252. And I would turn it over to you at this point and ask for your input. What should/could we do? It's up to you. Not seeing it? Okay.
Oh, they will.
Yeah, I just didn't know if you guys were going to reduce the fraction or not. But I want to teach this lesson with the idea that I want to do it the way your brain would tell you to do it. As your teacher, I would tell you, you should stop right here, going forward, and look for opportunities to make the numbers smaller. I'm not going to do it in this problem, but for you, you should divide the top and the bottom both by 2. Okay? So I'm just going to do it based on your silence a minute ago. I'm going to do it the way I think that maybe you would have done it. It's hard to remember all the things to look for. So I'm just going to say x equals positive negative root 108 over root 252. And again, absolutely maddening if you were to multiply the top and the bottom both by root 252. You'd get like, what is that, like 25,000 something? Holy buckets. I don't want to do that. So let's head off to the side and do a little bit of ahead of time work. How do you break down a root of 108? Which, by the way, you wouldn't be dealing with this had you reduced the fraction when you had a chance. Just kind of food for thought. Anyone remember this guy? It's one I would add to my notes page. No. It's something times 3.
Oh, 36.
Yes. It's good to have familiarity with roots. Just and every time you see one, you're just adding a little bit of knowledge into that memory bank. Like you see something and go, I know who you are. 108 to you should just be 36 times 3. And the reason why that's important is because now the top I can call a nice clean 6 roots of 3. Okay. 108. Every number has a best way to break it down. Every number. If it's breakable, it has a best way. Some of them have lots of ways, but there's always one best. How do we break down a 252? Nice job. Um, what is that? 210, 252, 36. So what does the bottom become? Nice. If you're not seeing today how important that is, that skill of breaking down roots, you're just not paying attention, right? So we learned that in Algebra 1. We've revisited it several times in Algebra 2. It's just a very fundamentally critical skill. You see anything right now that maybe we could grab? Yeah, why not get rid of those 6s? Well, just easy. I mean, get them out of the way now. Like you could keep them hanging around, but why? Let's knock them out. So at this point in the problem, our answer is positive or negative root 3 over root 7. I mean, you got a pair of free rational 6s. Poof, knock those guys out. And then it's go time. And this problem could have been a nightmare had we not seized opportunities along the way. But now it's just child's play. Easy. What do we multiply by? Root 7 on the top, root 7 on the bottom. What do we get on top? Root 21. What do we get on bottom? 7. Done. And if I catch you trying to reduce the 21 and the 7, you will serve 17 days of lunch detention, just FYI. Okay? Unless you can justify it, and then I'll knock it down to like 16. Okay? Deal? All right, remember, rational numbers and irrational numbers do not reduce with each other. Okay, we can reduce rationals with rationals. Roots we can tackle down, but not crossways. They don't play with each other. Any questions about that? Yes, sir.
Why didn't we divide the 108
By 2?
by 4?
Because no one told me to. So as a teacher, what I wanted to do was attack that problem the way I thought maybe you guys would have, based on the fact that no one wanted to say that. If I were doing it by myself, it would just me like making an answer key. I would have divided both of these numbers down. And you say they can both go down by 4? Yeah. Which proves that you could even keep going. Like, couldn't you divide those both by 9? Which would knock you down to 3/7. So, I mean, this opportunity to attack that fraction early that we missed hurt us maybe a little bit as we kind of drudged through the problem, but we got through, right? But seeing that would have made this a lot simpler of a situation. So whenever you divide both sides and you get to the critical, the red box step right here where it says x squared equals something, check this fraction. And if you can reduce it, you should. And if you miss it, all hope is not lost. You're just going to have a little bit of a harder time than someone who saw it. Got it? Okay, good.